13, find the x-coordinates of all the inflection points. So in order to do that, we need to use the second derivative. First, we can think of this a little differently, like 1 over 56 times x to the 8 minus 9 over 30. We can actually simplify to 3/10 times x to the 6th. So when we take the first derivative, bring the 8 out in front, 8 times 1 over 56 gives us 1/7 times x to the 7th, minus, bring the 6 out, 3 times 6, we get 18 over 10, or 9 over 5 times x to the 5th. Then second derivative, multiply by 7, we just get x to the 6th, minus 9x to the 4th. So we want to know when this is 0. We can factor out an x to the 4th. So we get x equals 0, or x equals positive or negative 3. I want to look at that on a number line. Figure out where the concavity is changing. This is our second derivative. The concavity changes from positive to negative at these points, because this is 0. Then we have an inflection point at those x values. So if we put in a value less than negative 3, so negative 4, negative 4 to the 4th is going to be positive. Negative 4 squared, 16 minus 9, that's going to be positive. Put in a number in between here, like negative 1. Negative 1 to the 4th is positive. Negative 1 squared is 1, minus 9 is negative. So positive times a negative is negative. Put positive 1 in, we get a positive number. For this, we get 1 squared minus 9. Again, we get a negative number, so it doesn't change there. We do have an inflection point at this point. Put 4 in, 4 to the 4th is positive. 4 squared, 16 minus 9. That's going to be positive times the positive is positive, so we have an inflection point here. So our inflection points are at x equals positive or negative 3.